Okay, so I was waiting to do this video for like the whole quarter because the programming class that I'm currently in, where we're learning assembly C and C++, utilizes trees a lot. So I wanted to make this video about on the chapter about trees and graphs. And so the chapter that I'll be covering in this video is chapter 10, Theory of Graphs and Trees. So to begin, one thing that I think could have been done differently by the author in the textbook to improve this chapter is to add coding examples for the different algorithms for the trees. Um, so when I looked at the physical graphs in the examples in the chapter, I was able to understand the concepts of the chapter that like they were trying to portray. And I understand that this class is a math class, but I also want to be able to take these concepts and be able to apply them into my programming skills. However, when it comes to the application of these programs for computer science, I don't think that I would have enough depth of understanding to be able to apply these algorithms into my code. Now, by seeing actual code that utilizes these algorithms, I would be able to better understand how to implement these algorithms into my code. So, another thing, sorry, that the instructor could do better for the lectures on the chapter is to use live annotations when teaching the concepts for this chapter, especially earlier in the earlier videos, especially with large or complex trees and graphs. It was hard for me to keep track of specific vertices or edges that the teacher was talking about. So by having live annotations for the slides, I would be able to keep better track of the different aspects of the graph that are relevant to the explanation of these concepts. Next, because I'm currently taking a CS class that occasionally uses trees, I was able to see that there were clear connections between mathematics and computer science in this chapter, specifically having to do with us being able to use mathematical knowledge to be able to design efficient data structures and algorithms for our programs. So more specifically, when looking at graph theory, it allows us to have an underlying mathematical framework which can be used to represent or analyze graphs and networks that we program in computer science. And as for trees, they are a very foundational part of computer science. By having a good mathematical understanding of trees, we can utilize these data structures to execute different tasks like searching or sorting. And to end off, if I could go back and start reading the chapter again, I would like to have a good establishment of the difference between graphs and trees. So when I first read the chapter, I already kind of had a basic understanding of trees, and this became a problem as I began to apply some of the principles that I knew about trees to graphs as well, which included principles such as connectivity, cycles, and ordering. And because of these assumptions that I made, it was only when I read about halfway through the chapter where I realized that graphs and trees and their properties can actually be very different, which caused me to have to go back and read sections about graphs and relearn them all again.